couple of years ago, I had a really long, heated debate with my nephew about the Second Amendment. And that also is a very long, slippery slope. So I don't want to start going down the slippery slope on reject the null hypothesis. Let's just keep it that way. I reject the null hypothesis. It's clear, it's succinct, and
Well, using the term fail to reject illustrates clearly the inconclusiveness of this.
yeah. And saying that I failed to reject the null, that's all you have to say. You don't have to go on and elaborate on that. It has very, very clear meaning.
What if we feel so strongly about something like Pythagorean's best work that we fail to reject the null on purpose? Kind of like, what does that mean?
Oh, well, that was mentioned at the start of class about, where they brought up this, you were concerned about the biases that researchers bring to their research.
Right.
So, yeah. Okay. Remember that the deconstruction movement started in the literature and departments at Yale. And so again, you're headed down a slippery slope. The deconstructionists at Yale, in Yale's literature department, claimed that the observer, by the act of observing, you know, they took the Heisenberg uncertainty principle and they went to extremes with it. What's the Heisenberg uncertainty principle?
The act of observing affects the thing that you're observing.
Right. And so the idea behind the Heisenberg uncertainty principle is that you can either measure its location, the particle's location, or its speed, but not both. And so the deconstructionists argued that by reading the novel, you altered its meaning. And that was their extreme form. By observing the physical phenomenon, you altered its meaning. So we don't want to go down that road. Okay. We want to steer clear of some of these.
One last question on the paper. Is there a page line?
Whatever number of pages it takes you to say. Less is better. There's nothing wrong with being concise. You don't have to go back and explain the history of the world to get to the point at which your paper has jumped off.
For the paper, can we use data that we've collected from a previous class or a different paper, or do we have to collect new data?
I do not want you to use this paper as a submission in another class. Because of some things that happened last year, I have to draw the line in the sand. You may not use this paper as a paper that you're writing for another class.
But can we use the same data that we gathered earlier, or does it have to be entirely new data?
You're headed down the slippery slope. You know, if you collected a big data set and you were doing some things in the data set for one class but had a set of questions that could be answered out of that data set, and we have another set of variables that are germane to some different questions, then sure. But if you think all you're going to do is, for this class, you're going to use the paper and you're going to write an essay based on some simple analysis of variance tests, and then you're going to come to this class and you're going to use the same data and the same variables and run a regression, forget that. There has to be a distinction between the two papers, some way, somehow. Okay. Anybody else? Most papers I've found are usually somewhere between 15 and 20 pages. Make sure your papers are double spaced with 1-inch margins so that I can write on them as I'm reading. let's spend a little bit of time on matrix algebra so that we can put it behind us and move on to more interesting things. And I hope that there are some lecture notes out on the web, and they're in one of the cells on the syllabus that you have. And so we're supposed to think about matrix addition, multiplication, inner products, independence of vectors, and some things like that. So just going through that stuff can be pretty boring. So instead, on the other screen, what I did was, now I remember what we want to look at. What I did was put together something in MathCAD. Now, one could do these simple things with pencil and paper or on your programmable calculator, but fortunately, the computer algebra programs are pretty powerful and they're useful for doing even simple examples. But one of the things that you can see is that when we're doing matrix multiplication, suppose we have A and B. In order for the two matrices to be multiplied, they have to be conformable, so that the number of columns in the first matrix equals the number of rows in the post matrix. So that you can multiply A times B, because the columns in A is the same as the number of rows in B. We can also multiply B times A, because in that case the number of columns in B is the same as the number of rows in A. But when we reverse the sequence of the A and B, the result changes in dimension. So the dimension of the product is determined by the number of rows in the first matrix, and the number of columns in the result is determined by the number of columns in the second matrix. And we can see that just by what was going on in MathCAD. So I don't know if you can see it from back there, but there's a little dot between the A and B for multiplication. So when you multiply A times B, you get that matrix. And when you multiply B times A, you get the 3 by 3 matrix, which is quite a different result. So it pays for you to keep in mind, you don't have to work out all the details with your pencil and paper, but when you're reading a little bit of algebra in your textbook, you have to sort of have running on the back screen of your brain what's actually going on. You have to be keeping track of the rows and columns. Sometimes it's really important to be keeping track of how the rows and columns are working out. When I'm lecturing, I'll point out to you places where it's important for us to keep track of conformability. It's also the case that everybody knows what the transpose of a matrix is. To think about it in a graphical way, if you have a matrix and you you write the matrix on a piece of paper and you cut it out, so that your point cut out is just the same, just around the matrix, and you put a needle through the main diagonal of the matrix, and you roll it 180 degrees on your fingers, you transpose the matrix. So you're swapping the first row into the first column, the second row into the second column, and so on and so forth. And the way you can think about imagining it being done is by writing the numbers on a piece of paper, sticking the needle through it, and then rolling the needle 180 degrees. Sometimes I find these little visual tricks helpful in explaining to myself what's going on. So, for example, one of the other things we could do here is we could act, in fact, we could do, so there's the transpose of A. So quickly you can see that we just took the first row out of A, we made it the first column, we took the second row out of A, we made it the second column, and so on and so forth.